Right, so it's now my great pleasure to tell you all about our plans for the future directions of the Spark technology, all within the next 15 minutes. I'll see how I can do on timing. So, just a quick reflection then on how we got to where we are today with Spark. It's an interesting reflection that actually Spark has been around for over 25 years now. If you look back to the origins of the technology, it's based in research that was going on. You might not be able to read the dates that I've circled in red, but paper about information flow analysis by Bergeretti and Carey is 85, and the original definition of the Spark language, 87 there, co-authored by Bernard and Trevor. So Spark has a long track record stemming from research done over 25 years ago. And in the intervening period, Spark has achieved quite a deal of success across a number of industry domains. So from civil avionics, secure biometric access control, advanced railway signalling, cryptography applications, various military applications, and smart cards, other secure system applications, such as the multi-level workstation, which Secunet are demonstrating for us here today. And many of these applications for Spark are very much in high-profile, mission-critical systems, such as IFACs that we heard about earlier on from Alan Robb, and of course Eurofighter Typhoon, to mention just two. During this 25 years, Spark has very much continued to evolve. So we've had versions of the language reflecting the different Ada language versions, 83, 95, 2005, and of course the addition of the Raven Spark tasking profile. And in 2009, as well, as a result of the partnership with Ada Core, we saw the release of Spark Pro, introducing updated interface to the tools and the environment, so the ability to download and report issues through GNAT Tracker, and the addition of the graphical user interface to the tools through the GPS and GNAT Bench IDEs. So in terms of the current context and influences that we have then, the desire to innovate with Spark continues to this day. We have strong links with the research community, collaborative research such as Highlight that's been mentioned, but also Victor with Paul Jackson at Edinburgh University, which has found its way into the current tools in the form of Spark Bridge, giving access to new alternative theorem provers. The Riposte project with Bath University, which has led to the counterexample generation capabilities which Martin presented earlier. And we have a number of Spark projects in the research community, such as Echo, the heart monitoring application, CubeSat, Ironsides, which is a secure DNS application. So as well as these links to the research community, we have the challenges and opportunities which have just been covered by Cyril and Rod. So the need for more efficient techniques in secure software assurance for high-grade security applications, which Rod was referring to, and the increasing demand for the combination of both safety and security in a lot of applications that we're seeing now, automotive, avionics, and so on. We have the opportunity that's presented by Ada 2012, as Cyril just demonstrated. Contracts have now found their way back into the mainstream Ada language. And the success of the Highlight project in demonstrating the feasibility of combining proof and unit testing as a verification approach in the DO178C context. So, given all of these influences, we're very pleased that the next generation of the Spark technology is now under development by Altran Praxis and AdaCore. So we're in the process of developing a new framework here for high assurance software that will comprise an updated version of the language, a powerful verification tool set, software engineering methods that go with these tools and the language. So in the same way that we have correctness by construction at the moment, providing a method for Spark, we need extended methods that will cover a combination of proof and testing, but also involving things like existing software and how the security, the safety and the verification of that can be improved. And of course, training in these methods for engineers wanting to use the tools and language. So, very quickly then, some highlights of what the next generation language and tool set will include. So the first thing to cover probably is the language in itself. So we have on the left-hand box there a very small example of what a contractualized program in the current Spark language would look like. Dependency relation with the derives, the pre and post conditions, giving the functional behavior, and an example of what this will look like in the new language. So what we're doing here is we're using the capabilities within Ada 2012 to represent the Spark contracts, the pragmas, the with statements, attributes, and the aspects given by the with statement, and also attributes and pragmas will be used to define the syntax for the new versions of the Spark contracts. But importantly, of course, this still being a valid Ada 2012 program, so retaining the property that a Spark program will be compilable by any Ada 2012 compatible compiler. And of course, the feature mentioned by Cyril that whereas in Ada 2012 the original concept of contracts was that they are executable contracts, in order to statically verify, we of course need to be able to take a mathematical view of the contracts in addition to the executable view that's provided by the compiler. So, the new language then will be a bigger subset of Ada than we currently have in Spark. Essentially, the largest subset will include everything in the language except pointers, exceptions, and goto, of course. So this means, relative to the current language, this means the addition of things like dynamic types, array slices, discriminant records, early return statements. But what we will do on top of this is to define a number of profiles that allow users to restrict that largest subset down to more focused subsets that might be applicable to a particular application. So we would have a profile for server-based applications, a profile for embedded systems, and so on, where that latter would be closer to the current day Spark in terms of its restrictions. So looking then briefly at the new features that we'll be looking to add to the tool set, well, first of all, of course, it will provide the facility for combining both proof and robustness testing as a verification approach. It's already been described by Cyril. We will also provide a formal container library. So this is a container library which provides people with the ability to write code on top of that and formally prove their own systems. We will provide more advanced information flow analysis capabilities, so answering the demands in the security market. A couple of points here. So we're looking at providing visualization of information flows. So this is the slicing capability, as it's sometimes called, that KSU are demonstrating for us today. The ability to be able to select a program variable and see how information flows through it. So you can imagine that would be valuable to an assessor, somebody looking at the security of a program, trying to understand how information flows through that program. We will provide increased refinement of the information flow contracts as well, so the ability to be able to look at information flow at an array element level. We're also going to be adding what we're calling a generative mode to the use of the tools. So we already have flexibility in the way that the tools can be used, in the sense that you can choose what level you're analysing at: data flow, information flow, proof of absence of runtime errors, full functional property, proof of partial correctness, if you want to call it that. But we will add new ways of using the tools. So a generative mode. This means that given a procedure, an uncontractualized procedure, being able to calculate, given the body of that procedure, what the dependency relation is. So there might be a couple of modes of use here that could be of interest. If you were a user and you just wanted to understand more about the behavior of your program, you could ask the tools to generate the dependency relation for you. But we're also seeing this as a way of getting from uncontractualized code to a point where you've added contracts to your software. So we're talking about the ability to be able to bless a contract, if you like, is the term that we're using. The tools will calculate the dependency relation for you, offer it to you, and you will have the ability to add it to the code. So you start to get assistance to contractualize your program from the tools. We'll provide a powerful verification tool set for proving functional properties. So we've always sought to improve the performance of the proof tools within the Spark tool set. Improvements to the simplifier, and the addition of Spark Bridge and the use of Victor to provide a bridge now to alternative theorem provers. And we'll continue that with the new tool set, building on the power of SMT solvers. And we will also provide improved diagnostic capability for unproved verification conditions. So Martin's touched a bit on this earlier on in his talk in the technical track, the issue of what happens when you have a VC that you can't prove. Well, a couple of things will be added that will help with this. First of all, the display of paths that lead to the failure to be able to prove a VC. So this is a screenshot that's taken from prototype tools that have come out of the Highlight project. And as I mentioned, the counterexample generation capabilities that Martin talked about earlier. If you want to see more about this, we can demo at the back of the room on the Spark table if people are interested to see more. So, when will all this new functionality be available? The first release of the next generation of the Spark tools will be Q1 of 2014. Important to realise that this will be available alongside the current Spark Pro toolset and language. So, whereas in the past we've always added profiles, language profiles, and support for previous language versions has remained, the same policy will be applied, because of course we recognise that people have long-term projects and need ongoing support for a particular language version within that project. So we'll continue to maintain Spark Pro and the current version of the tools and the language. We will provide a beta release preview for current Spark Pro customers during 2013, so people will be able to get access to prototypes of the tool set for those interested. And we will be working on the language definition in conjunction with an advisory panel, industrial advisory panel, that will provide us input and views from different industry sectors, so from defence, from avionics, and from the security domain, to make sure that we're gathering the requirements of our customers and feeding those into the new language definition. So that's a very brief tour of what we see in the next generation of Spark. We will, of course, be keeping people up to date with further information as we get closer to the launch date. If you need further information in the meantime, we have time for some questions within the constraints of not being too late for lunch. After that, there are lots of members of the Spark team here today from Altran Praxis and ADCore, so please do come and find us and ask us questions. And failing that, myself, Mikhail Fries, are of course always available to contact to ask further questions. Thank you very much.